Hi everyone. I'm gonna introduce the HTTP protocol today. Uh, so um, for the overview of HTTP, um, the the HTTP stands for Hypertext Transfer Protocol. The web's application layer protocol defines how web clients request web pages from web servers and how servers transfer web pages to clients. HTTP is implemented in two programs, a client program and a server program. The client program and a server program executing on different end systems talk to each other by exchanging HTTP messages. HTTP defines the structure of these messages and how the client and server exchanges the messages. Web servers such as Internet Explorer and Firefox implement the client side of HTTP. Web servers, which implement the server side of HTTP, house objects, each addressable by a URL. Web servers include uh, Apache and Microsoft Internet uh, Information Server. When a user requests a web page, for example, when a user clicks on a hyperlink, the browser sends HTTP request messages for the objects in the page to the server. The server receives the requests and responds with HTTP response messages that contain the objects. HTTP uses TCP as its underlying transport protocol. The HTTP client first initializes a TCP connection with the server. Once the connection is established, the browser and the server processes access TCP through the socket interfaces. The client sends HTTP request messages into its socket interface and receives HTTP response messages from its socket interface. It is similar for the HTTP server. TCP provides a reliable data transfer service to HTTP. HTTP servers maintain no information about the clients. HTTP is said to be a stateless protocol. A web service is always on with a fixed IP address, and it services requests from potentially millions of different browsers. So, um, for HTTP protocol, there are two different connections. They are the non-persistent and persistent connections. For non-persistent connections, all request response pairs sent over a separate TCP connection. Um, and for persistent connections, all requests slash response pair sent over the same TCP connection. Um, HTTP can use both non-persistent connections and persistent connections. HTTP uses persistent connections in its default mode. However, HTTP clients and servers can be configured to use non-persistent connections instead. So, non-persistent connections, where each TCP connection is closed after the server sends the object, connection does not persist for other objects. Note that each TCP connection transports exactly one request message and one response message. Thus, when a user requests the web page of 11 objects, 11 TCP connections are generated. Non-persistent connections have some shortcomings. First one is a brand new connection must be established and maintained for each requested object. This can place a significant burden on the web server, which may be serving requests from hundreds of different clients simultaneously. Secondly, each object suffers a delivery delay of 2 round trip times. For for HTTP with persistent connections. With HTTP 1.1 persistent connections, the server leaves the TCP connection open after sending a response. Subsequent requests and responses between the same client and server can be sent over the same connection. In particular, an entire web page with numerous objects can be sent over a single persistent TCP connection. Moreover, multiple web pages residing on the same server can be sent from the server to the same client over a single persistent TCP connection. These requests for objects can be made back to back without waiting for replies to pending requests. Uh, this section is about HTTP message format. There are two different types of HTTP messages. They are request messages and response messages. The first line of a HTTP request message is called the request line. The subsequent lines are called the header lines. The request line has three fields: the method field, the URL field, and the HTTP version field. The method field can take on several different values, including get, post, head, put, and delete. The great majority of HTTP request messages use the get method. The get method is used when the browser requests an object with the requested object identified in the URL field. The version is the version uh, the HTTP version field is the version of HTTP that is desired. The header could contain information such as host selection, host specification, whether to connect with persistent connections, browser type of the client, and the language preference. Um, sorry. Uh, the entity body is empty with the note on the right picture here. The entity body is empty with the get method, but is used with the post method. An HTTP client often uses the post method when the user fills out a form. If the value of the method field is post, then the entity body contains what the user entered into the form fields. On the right is an example response message. Um, the example response message has three sections: an initial status line, six header lines, and then the entity body. The entity body is the meat of the message. It contains the requested object itself. The status line has three fields: the protocol version field, a status code, and a corresponding status message. In this example, the status line indicates that the service is using HTTP 1.1 and that everything is okay. Um, on the right, the connection header is for to close header line to tell the client that it is going to close the TCP connection after sending the message. For the date header line, it indicates the time and date when the HTTP response was created and sent by the server. For the server header line, it indicates that the message was generated by the Apache web server. For the last modified header line, it indicates that the time and date when the object was created or last modified. For the content length, um, it indicates the number of bytes in the object being sent. This is a general format of an HTTP response message. So now I'm going to introduce the concept of cookies. Cookies allow sites to keep track of users. Most commercial websites use cookies today. As shown in the figure, um, sorry. Um, so cookie technology has four components. Number one, a cookie header line in the HTTP response message. Number two, a cookie header line in the HTTP response message. Three, a cookie files kept on the user's end system and managed by the user's browser. And four, a back-end database at the website. Um, Next up is web caching. A web cache is also called a proxy server. It is a network entity that satisfies HTTP requests on the behalf of an origin web server. The web cache has its own disk storage and keeps copies of recently requested objects in its storage. So I'm going to introduce what happens when a browser requests an object. So what happens is, number one, the browser establishes a TCP connection to the web cache and sends an HTTP request for the object to the web cache. In step two, the web cache checks to see if it has a copy of the object stored locally. If it does, the web cache returns the object within an HTTP request message to the client browser. For step three, if the web cache does not have the object, the web cache opens opens a TCP connection to the original server. The web cache then sends an HTTP request for the object into the cache to server TCP connection. After receiving this request, the origin server sends the object within an HTTP request to the web cache. For the last step, when the web cache receives the object, it stores a copy in its local storage and sends a copy within an HTTP response message to the client browser. So web caching has seen deployment in the internet for two reasons. A web cache can substantially reduce the response time for a client request, particularly if the bottleneck bandwidth between the client and the original server is much less than the bottleneck bandwidth between the client and the cache. Second, web caches can substantially reduce traffic on an institution's access link to the internet. Lastly, I'm going to introduce the conditional get. It is an HTTP mechanism that allows a cache to verify that its objects are up to date. This mechanism is called the conditional get. An HTTP request message is called a conditional get message if number one, the request messages the request message uses the get method, and number two, the request messages includes a if modified since header line. That's all for my presentation. Thank you.